The answer to the previous post is D. Albert Einstein. General relativity is physicist Albert Einstein's understanding of how gravity affects the fabric of spacetime. The theory, which Einstein published in 1915, expanded the theory of special relativity that he had published 10 years earlier. Special relativity argued that space and time are inextricably connected, but that theory didn't acknowledge the existence of gravity. To understand general relativity, first, let's start with gravity, the force of attraction that two objects exert on one another. Sir Isaac Newton quantified gravity in the same text in which he formulated his 3 laws of motion, the Principia. 8 applications of Einstein's theory of relativity in real life. Magnetism is a relativistic effect, and you can see this demonstrated in generators. If you take a loop of wire and move it through a magnetic field, you generate an electric current. The charged particles in the wire are affected by the changing magnetic field, which forces some of them to move and creates the current. GPS navigation to function as accurately as it does, satellites have to consider relativistic effects, according to Physics Central. This is because even though satellites aren't moving anywhere close to the speed of light, they are still going pretty fast. Gold's yellow color. Most metals are shiny because the electrons in the atoms jump from different energy levels, or orbitals. Some photons that hit the metal get absorbed and re-emitted, though at a longer wavelength. However, most visible light gets reflected. Gold is a heavy element, so the inner electrons move fast enough that the relativistic mass increase and the length contraction are significant, according to a statement from Heidelberg University in Germany. As a result, the electrons spin around the nucleus in shorter parts, with more momentum. Electrons in the inner orbitals carry energy that is closer to the energy of outer electrons, and the wavelengths that get absorbed and reflected are longer. Gold resistance to corrosion. The relativistic effect on gold's electrons is also one reason it doesn't corrode or easily react with anything else, according to a 1998 paper in the journal Gold Bulletin. Gold has only 1 electron in its outer shell, but it still is not as reactive as calcium or lithium. Instead, because the electrons in gold are heavier than they should be, since they are moving near the speed of light, increasing their mass, they are held closer to the atomic nucleus.
Don't forget to follow us for more video.